This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. Sometimes, when we draw a histogram, we find that the data values tend towards a central value, and we end up with a bell-shaped distribution. We can see this more clearly when I draw in the curve of the distribution. Now we can see the curve is bell-shaped. If the distribution has a few more properties, it is a normal distribution. The first property is that it's symmetric around its central value. We can see here that the left-hand side and the right-hand side of the distribution are symmetric to each other. The next important property is that the mean, the mode, and the median are all equal to each other. This is represented also by the blue line, the line of symmetry. Normal distributions are the most common probability distributions. They are used for continuous data. If we recall back to the histogram video, histograms are used for continuous data. Data is often naturally normally distributed. For example, heights of people are normally distributed, or sometimes grades can be normally distributed. Now we have three normal distributions. Their bell shape is the same. What's different about them is where their line of symmetry or their mean, mode and median position is. For the red distribution, we have the mean at 10. For the blue distribution, we have the mean at 20. And for the green distribution, we have the mean at 30. It does not matter what is the mean for the normal distribution. The width of the normal distribution, or by how much the values cluster together, is dictated by the standard deviation. In the next case, there are two normal distributions, but in this instance, they both have the same mean, median and mode, or line of symmetry. However, their standard deviation differs. In case of the blue normal distribution, the values are clustered together. This would indicate a lower standard deviation. In the case of the red normal distribution, the distribution is more spread out. This would indicate that the dataset this distribution is representing has more spread out values and therefore a higher standard deviation than the blue normal distribution. Another requirement for a distribution to be a normal distribution is that the empirical rule must hold. The empirical rule states for a normal distribution, 68% of the data falls within one standard deviation of the mean, 95% falls within two standard deviations, and 99.7% falls within three standard deviations. Let's have a look at this on a normal distribution. Now to draw my normal distribution. The line of symmetry is at the mean, and this is represented by the Greek symbol mu. The first part of our empirical rule states that 68% of the data falls within plus or minus one standard deviation. So drawing it in here, there's the mean plus one standard deviation. This is the mean minus one standard deviation. So if a data value is picked at random from our data set, there's a 68% chance it'll lie between this boundary. The next part of the empirical rule states that 95% of the data lies between plus and minus two standard deviations. So we'll mark in mu plus two standard deviations, which is the mean plus two standard deviations, and mu minus two standard deviations. And the rule says 95% of the data will be in this region here. The last point of the empirical rule says that 99.7% of the data will fall between plus and minus 3 standard deviations. That covers all this area under our distribution. We use the empirical rule as a quick estimate of the spread of data in a normal distribution. Now let's look at some empirical rule questions. The question states that the weights of 200 students in a school are normally distributed, with mean 70 kilos and a standard deviation of 10 kilos. What percentage of students weigh between 60 and 80 kilos? We are going to use the empirical rule to solve this question. Firstly, I'll use a drawing of the normal distribution. I'm going to firstly fill in where the mean is for the normal distribution. In this case, it's 70. This red line here represents the mean plus 1 standard deviation. So in this case, it'd be 70 plus the standard deviation of 10, which will give us 80. The next line, the blue line here, is the mean plus 2 standard deviations. So the mean of 70 plus 2 times 10, which is plus 20, will give us 90. Then we move on to the green line. This is the mean plus 3 standard deviations, so that'll give us 100. Working backwards, this red line here is the mean minus 1 standard deviation. So 70 minus 1 times 10 is minus 10. 70 minus 10 will give us 60. This blue line here is the mean of 70 minus 2 standard deviations of 10. That gives us 50. And the last green line represents the mean minus 3 standard deviations. The question asks us to find what percentage of students weigh between 60 and 80 kilos. So using our diagram, we can see this is the mean minus 1 standard deviation and the mean plus 1 standard deviation. Our empirical rule tells us that this is 68% of the data. So the answer to our question is 68%. We could have also done this question mathematically by working out how many standard deviations from the mean was 60 and 80 kilos. To do this, we'd say mu, the mean, plus a number which we'll represent by x, standard deviations, equals 60. So 70, which is our mean, plus the standard deviation is 10 times the number equals 60. Solving this, we'll have 70 minus 60 is equal to minus 10x when we bring things across the equals, and we'll have 10 is equal to minus 10x and x is equal to minus 1. So 60 is minus 1 standard deviations from 70. We can do this for 80 kilos as well. If we repeat this method for 80 kilos, we'll find x is equal to 1. So 60 and 80 kilos are plus and minus 1 standard deviation from our mean. So going back to our rule and the first point there, this means that 68% of the data is between 60 and 80 kilos. We'll move on to another question. What is the probability a student weighs more than 100 kilos? From our diagram, we can see that the 100 kilos is at mu plus 3 standard deviations. From our point 3 of the empirical rule, we know that 99.7% of the data lies between plus and minus 3 standard deviations of the mean. This means the remaining area on the left hand side of the distribution and the right hand side contains 0.3% of the data. We get this from taking away 99.7% of the data from 100% of the data. So this 0.3% of the data is in the left-hand side of the distribution and the right-hand side of the distribution. Now remember that a normal distribution is symmetric. This means the same amount of data should be in either of these locations. So dividing it between 2, as there are 2 sides, we find that 0.15% of the data is in this top tail here. If it's 0.15%, the probability is equal to 0.0015 when we convert. So the answer is 0.015. Now moving on to one more question. The last question asks us how many students are within 2 standard deviations of the mean. From point 2 of our empirical rule, we know 95% of students are within 2 standard deviations of the mean. From the question, we know there are 200 students. So if we find 95% of the 200 students, we will find how many students are within 2 standard deviations of the mean. 95% of 200 students is 180 students. That concludes our discussion on the normal distribution and the empirical rule.